Hello, are you ready for it?
A compound is found to contain 63.52% iron and 36.48% sulfur. Find its empirical formula. So again, if you are given a percentage, you assume that the total mass is 100, so that the percentage is equal to the grams, 63.52 and 36.48 grams. If you have the number of grams or the mass, you have to get the number of moles. So 63.52 grams of iron times 1 mole over 55.85 grams. This is the molecular mass. You have to get this from the periodic table. So canceling the units, you will get 1.137 moles of iron. Now let's get the number of moles of sulfur. So we have 36.48 grams of sulfur times 1 mole, 32.06 grams mole of sulfur. Okay. So now we have both the number of moles for iron and sulfur. The next step is to divide it by the smallest number of moles, which is the moles of iron. So 1.137 moles of iron divided by itself, we will have 1. And 1.138 moles of sulfur divided by 1.137 moles, we will have approximate of 1. So the empirical formula is FeS.
How do you do what you do?
A compound is found to contain 26.56% potassium, 35.41% chromium, and the remainder oxygen. Find its empirical formula. Okay, so we have the percentage for potassium, which is 26.56, 35.41 for chromium, but we don't have the percentage of oxygen. So what we have to do is to get the percentage of oxygen first. So let X percentage of oxygen plus 26.56% for potassium plus 35.41% for chromium equals 100. Now, if you solve for X, we will get 36.96%. Now, let's use this to get the number of moles. And we all know that 26.56% is equal to 26.56 grams. 35.41% is just 35.41 grams. And for oxygen, we have 36.96 grams. Multiply them by their molar mass, we will have 1 over 39.10 grams times 1 mole over 52.00 grams times 1 mole 16.00 grams. Now cancel the grams. This one we will get 0.6793 moles of K. We will have 0.7015 mole of chromium, and we will have 2.310 mole of oxygen. The next step is to divide them by the smallest number of moles. So we will have 0.6793 divided by itself. We will have 1. 0.6793. We will have 1.033. Then this one divided by 6793, we will have 3.401. Since we have 3.4, we have to multiply the number of moles to the smallest number that will give us an integer. So you have to multiply this by 2. Okay, so if we multiply this by 2, we will have 6.802, and this is equal to 7 if you round it off. Then chromium will have 2.066, and for potassium, we have 2. The empirical formula will be K2Cr2O7.
What's not clicking? What's not clicking?
A 60-gram sample of tetraethyl lead is found to contain 38.43 grams lead, 17.83 grams of carbon, and 3.74 grams of hydrogen. Find its empirical formula. Okay, so in this question, you don't have to convert anything. You can use the masses directly to solve the number of moles. 3.43 grams of lead multiplied to its molar mass, we will have 1 mole over 207.20 grams. Cancel the unit, we will have 0.1855 moles of lead. Now let's get the number of moles of carbon. So we have 17.83 grams times its molar mass. We will have 1 mole over 12.01 gram. Cancel the unit. We will have 1.485 mole of carbon. Now let's get the number of moles for hydrogen. So 3.74 grams of hydrogen multiplied to its smaller mass, we will get 1 mole over 1.01 grams. This will give us 3.78 mole of hydrogen. Okay, so the next step is to divide these moles to the smallest number of mole. So we have 0.0.1855 moles. So 0.1855 mole divided by itself, we will have 1. And 1.485 divided by 0.1855, we will have 8.005 mole of carbon. Then this one, we will get 20.4 moles of hydrogen. Okay, so the empirical formula will be PbC8H20. So question, why didn't we multiply this by 2 since you have 4? We didn't multiply this by 2 because if you multiply them by 2, you will still get the same answer after you get the simplest ratio. So it will be like this: PB2C16H40. Okay, so if you get the simplest ratio, you will still get the same answer, PbC8H20. So you don't really have to multiply this moles by 2. Okay, so determine the molecular formula of the compound with an empirical formula of CH and a formula mass of 78.110 units. Formula mass is the sum of the masses of atoms present in the empirical formula. On the other hand, molecular mass of a molecule is the mass of a mole of that molecule. So formula mass, just remember, is calculated in AMU, or atomic mass unit, and molecular mass or molar mass is calculated in grams per mole. Okay, so what you have to do here is to get the number of units of each atom. So you have carbon and hydrogen. So carbon, one atom of carbon is equal to 12.01 units over one atom. Okay, so notice that the atomic mass and the molar mass are numerically equivalent. So this will give us 12.01 units. One atom of hydrogen is equal to 1.01 unit per one atom. So solving for unit, we will have 1.01 unit. Therefore, the empirical formula is 13.02 unit. Okay, so notice that you have a molecular formula mass of 78.110, right? What you need to do is to divide this from this. Okay, so we will have formula mass 78.110 unit divided by this one. We will get 13.02 unit. This will give us 5.999. So the molecular formula is C6H6. Why? You have to multiply this to your empirical formula CH. So CH times 6, boom, boom. You will get this.
Okay, let's move on.
Let's calculate an empirical formula given a percent composition data. Let's have this problem. A bromoalkane contains 35% carbon and 6.57 hydrogen by mass. Calculate the empirical formula. Remember that a bromoalkane consists of the halogen bromine, alkane, which is a hydrocarbon, C and H. If you notice, if you add these two, this will only give us 41.57%. So this is only hydrogen and carbon. And again, we have bromine. So to get the percentage of bromine, you have to subtract 41.57 from 100. This will give us 58.43% bromine. Now that we all have the percentage, let's assume that 100 grams of compound is available. So this means that carbon will be 35 grams, hydrogen will be 6.57 grams, and bromine will be 58.43 grams. The next step is to determine the number of moles. You do this by multiplying it to the molar mass. So 1 mole divided by 12.00 grams. This will give us 2.917 mole. This one, just divide this by 1 gram per mole. We will have 6.57 mole. Then bromine, just divide this by 80 grams per mole. We will have 0.730375 mole. The next step is to divide these moles by the smallest number of moles, which is this. So this one divided by 730,375 is equal to 1 divided by 0.730. This will give us 9. So this will give us 4. So the empirical formula will be C4H9Br.
Thanks everybody for coming out. I know y'all didn't expect me. Thank y'all so much, especially you in the back right now.
Now let's have a harder problem.
Getting tired now, though, to me. In the beginning, I was like, okay, it's cool, ha.
A compound containing sodium, chlorine, and oxygen is 25.42% sodium by mass. A 3.25 gram sample gives 4.33 times 10 raised to 22 atoms of oxygen. What is the empirical formula?
I know a lot of things, but I don't know about that.
The first thing that you need to do is to get the percent oxygen in the sample. And you are given the number of atoms. So remember Avogadro's number.
I mean, is that allowed?
So you have to divide the number of atoms by the Avogadro's number. So 6.022 times 10 to 23 atoms per mole. This will give us 0.071903 moles. Now that you have the number of moles, you multiply it to the molar mass of oxygen times 16.00 grams, 1 mole, cancel mole. This will give us 1.15045 grams of oxygen. So you have the mass. Now to get the percent, you divide this mass to the sample, 3.25. times 100. This will give us 35.40. Now let's get the percent of chlorine. So 100 minus 25.42 times 35.40 is equal to 39.18%. Now that we all have the percentage of sodium, chlorine, and oxygen, we can now get the empirical formula. Sodium is equal to 25.42 grams divided by 23.0 grams per mole. This will give us 1.105. For chlorine, we have 39.18 grams divided by the molar mass, 35.453 grams per mole. This will give us 1.105. And for oxygen, we'll have 35.40 grams divided by 16.00 grams per mole. This will give us 2.2125. Now, the next step is to divide this to the smallest number of moles. So we have 1.105 for that. So this will give us 1, 1 will give us 2. So the empirical formula is NaClO2.
Got it.
A sample of a compound with a formula mass of 34 units is found to consist of 0.44 grams hydrogen and 6.92 grams oxygen. Find its molecular formula. In this question, you're not given the empirical formula. So the first thing that you need to do is to get the empirical formula. 0.44 grams of hydrogen times its molar mass, 1 mole, 0.01 grams. Cancel the unit. We will get 0.436 mole of hydrogen. Now for the oxygen, same procedure. Multiply it to the molecular or the molar mass, 12.01 grams. Cancel the unit. This will give us 0.433 mole of oxygen. Now divide this to the smallest number of moles. This will give us 1 is 1.01 H. Now we have the empirical formula HO. Now let's get the molecular formula. So again, to get the molecular formula, you have to get the number of units of each atom. One atom of hydrogen times the atomic mass unit, which is 1.01 U over one atom of hydrogen. This will give us 1.01 U. Now, one atom of oxygen, one atom oxygen, this will give us 12.01 units. Get the empirical formula mass. This will give us 17.01. Then we have the formula mass of 34.00 units. So multiply this with this, we will have 34.00 U, 17.01 U is equal to 1.999 or 2. So the molecular formula will be HO times 2. This is H2O2. H2O2 is commonly known as hydrogen peroxide.
It never ends well for me in my mental state. So, bye!